Hi everyone, welcome to our third and final lecture example on de Moivre and Euler's theorem. Okay, so hopefully you've watched the first two videos and this is the third and final video. Okay, so let's begin with our example. So this is example 3. Example 3, find the value of cos I ln 3. So ln, that's a natural log. So what we're trying to do here is we're just trying to get a value out. Now, whether that's real or imaginary, that is another story, but we're trying just to get a value out. So the first thing we need to do is we need to recognise that this is something else in disguise. So the cosine of I theta is equal to cos of theta. So that means in this example, cosine of I natural log 3 is equal to the cos of the natural log of 3, or cos ln 3. So that would be the first step here, would be recognising that formula. Now these are all in the formula sheet, so don't panic about remembering them, that's not a problem. So that would be your first stage. Now what do you do? Well, we can write cos, and we should know that from the previous lecture example, in terms of exponentials. So that's what we do next. So what we do here is we write it in terms of exponential. So here ln 3, that's your x term. So instead of the normal form of the cos is being e to the x plus e to the minus x, we're replacing x with ln 3. So that's what we've got here. We've got e to the ln 3 plus e to the minus ln 3 equals 2. Now what we need to do here is we need to make use of our exponential and natural logarithmic rules. So these will be littered throughout the slides. So make sure you're aware of those because those won't be provided on the formula sheet. So e to the natural log of x is equal to x. That's just your first rule. And then if you've got a natural log of b raised to the power of a, you take the power down into the front, so that becomes a log b. And it's these two rules that we're going to make use of to solve this problem. So e to the natural log of 3, that's just equal to 3. The e and the natural log kind of cancel each other out, and we're left with the 3. Then e to the minus natural log of 3, the minus comes up, and it's a minus, so it's going to be a minus 1 when it comes up. Now remember, in order to cancel an e and a natural log, they need to be touching, they need to be side by side. So right now that minus sign was stopping them from being side by side, so we need to move that. And then what we're left with is 3 plus 3 to the power of minus 1, because that e and that natural log are right beside each other now, so they can sort of cancel out. Okay, so what do we do now? Because this looks a wee bit not great. So on the next slide, we've got another rule. This is instead of a rule of indices. So x raised to a minus power is equal to 1 over x raised to that power. So that means that 3 to the power of minus 1 is equal to 1 over 3 to the power of 1, or just 1 over 3. Anything raised to the power of 1 is just itself. So we've got 3 plus 1/3 all over 2. Now this looks horrible. So what we need to do now is we need to get rid of that third. So how do we get rid of that third? What we do is we times top and bottom by 3. So remember, 3 over 3, that's equal to 1. So we're not changing the value of our fraction at all. So 3 times 3 makes 9. 1/3 times 3 makes 1. And then 2 times 3 on the bottom, that makes 6. So we've got 9 plus 1 gives us 10. 10 over 6. And that simplifies to, if we divide top and bottom by 2, 5 over 3. And that's us. That's our final example of the class. So hopefully you've enjoyed the class, and remember, if you've got any problems, don't be scared. Just send me an email and we'll get it sorted via Skype or email or even a phone call. Okay, thanks for watching. Bye.